Okay, welcome in. In this video, we're going to be talking about Dplyr, which is a really cool kind of package. I don't even know if package is the word, kind of really cool environment set of tools that's used for R to do a lot of interesting types of data analysis in a fast and streamlined way. So let's get right into it. The first thing you're going to want to do, make this a little bigger, is to load the Dplyr library. That's going to give all the functions that we need. Should be pretty easy to install, and we're going to see some of those functions in a second. For this specific video, we're going to be working with the iris dataset, which is a dataset that's native to R, which means you can just do this data function and call iris. And now if I try and looking at the head of iris, the first 6 rows, I can see it's automatically loaded in my session. So I have a bunch of columns. This is like data about specific flowers, the length of the sepal, which I guess is a part of the flower, length of the petal, the width of the petal, and then the species. And we can just see some things about this data set. It's got 150 rows and these 5 columns. So the first kind of tenet of Dplyr is this thing that's called piping. And that is what we see here. So we're feeding in iris, which is the name of our data set, and we're piping it into future commands. I guess this kind of looks like a pipe because we have kind of this like little arrow and then these parentheses surrounding it. And this is a special, I guess it's considered a function, a special operator that's part of the Dplyr package. So if you don't load the Dplyr package, this will not work. We have Dplyr, so we're able to load it. And what this does is it passes, it's a pipe, pipes kind of pass things through them. It passes iris, the data set, into the next function. The next function is a function called filter, which, as you can imagine, filters out the data set. So what we're doing is we're passing iris into filter. And what's cool is when we do this piping thing, the pipe basically takes the data that we're passing in, and it enters it as the first argument in the next function. So if I ran this, I run iris filter sepal length greater than or equal to 7. As you might expect, that's just filtering the iris data set by the sepal lengths, the flowers, the rows that have a sepal length that's greater than or equal to 7. And you can see here, all these values are greater than 7. I have kind of these 13 rows. Now, that's the same as if I just type from scratch, filter iris sepal length greater than or equal to 7, I would get the same result. But what's nice about Dplyr is I don't have to type this extra kind of iris at the beginning. I can just pipe it in, with this piping function. Seems like that like doesn't help, but we're going to see soon why that's really useful. So that's kind of the basics of piping. Another really important Dplyr function is mutate. Mutate is the same thing as creating or generating a new column. So in this case, we're piping iris in. Again, you can imagine that iris is the first element here, but it's not because the pipe passes it through. We're going to define a new column, the petal area, which is just petal width times petal length. And if I run this, I'm going to get in my memory, you can see, here, let me do just the first 6 rows. The first 6 rows, I have this petal area is equal to this column, the length times the width, which is pretty cool. And that's what mutate is doing. It's saying establish this new petal area column, which is the width times the length. And notice that I'm just printing this to the console. It's not automatically saving. Like if I look at iris, there's no petal area column. Okay, so if I wanted to actually save this to iris, I'd have to assign it to iris. But for now, we're just kind of printing and seeing how it works. Okay, so the best thing about piping is you can string together multiple commands, right? So in this case, I'm going to pipe iris into mutate and create a new column called petal area. Then I'm going to take that resulting data set and pipe that into filter and filter out values for rows that have a petal area greater than or equal to 12. And then so if I do that, right, I can see I've created this petal area column and I filtered on it. I only have values that are 12 and up. And then if I can filter that again into summarize, and summarize is something that takes the mean, it can take the mean, it can take the variance, it can take whatever. We create this new kind of column called mean, and we take the mean of the sepal length. And if I run this whole thing, I'm going to get the mean as 6.92. So that's really cool because I didn't have to type iris much. I just kind of piped iris into these other things. And let me show you how that might take a longer time if I did it another way. I could say iris petal area is equal to iris petal width times iris, capitalized iris petal length. That's going to initialize my petal area column. Then I could filter iris. So iris where petal area is greater than or equal to 12. And then, oh, did I spell something wrong? Yeah, maybe I have to do this. So I'm selecting the rows where it's greater than or equal to 12, and then all the columns. Yeah, so that's my iris. And then I'm going to take the mean of iris petal length. And going to get hopefully the same result. Oh, sepal length, not petal length. Boom. And I get the same result as when I just run the dplyr, the 6.92. So two different ways to do it. Maybe you prefer this way. I tend to do this way, but this is really cool because you don't have to type iris as much. You don't have kind of these awkward dollar signs. Like everything here is very clear. We add this new column, we filter by this new column, and then we summarize by the other column. And it's very readable. You can imagine if you have like 15 of these commands, it's really easy to pipe them together and really neat. So hopefully that makes sense. And I'll link some more dplyr stuff below, and hope you enjoy using it.